MyCF, an easy way to model anatomy. MyCF is a web application providing anatomy knowledge structured by an ontology associated with a detailed anatomical 3D model. Its knowledge base is validated by medical practitioners. MyCF provides sophisticated tools that allows users to learn anatomy and help them model anatomical entities and functions for physically based simulation. These models can be used for graphics and medical purposes. Let's explore an anatomical entity, the liver. By selecting the liver, we can see a 3D mesh associated and we can access to its informations in a channel box. Information such as type, description, relations with other anatomical entities are extracted from the knowledge base. We see that the liver is a viscera and an organ and that it contains a dome, a lobe, etc. By associating 3D visualization and anatomy knowledge, MyCF is a tool to easily understand and learn anatomy. To facilitate the navigation, the selection tool is used to generate sets of anatomical entities. Standard selections are provided to isolate structures and help the user navigate and access data. For instance, we provide a head, a right arm, and a torso selection showing muscles, bones, and organs. The user can also create his own selections. A unique feature of MyCF is to propose selections based on anatomical functions. Let's make a selection of the knee flexion function. Achieving this task by proceeding entity by entity like before would require advanced anatomy knowledge and would take a lot of time. By taking advantage of the relations between anatomical entities and physiological functions, we can automatically select all the anatomical parts involved in a given function using requests in the ontology. Using the result of the requests, we can select what we consider interesting and use it to build our selections. The viewer displays the 3D visualization of the selection and allows interaction with the associated models. We can also change the character to fit our needs and work with our own models. For instance, to study anatomy using the zygote body, this model can be added and visualized in MyCF. This simply requires to rename the data files according to the standard terminology. In addition, MyCF contains mechanical data and parameters necessary to create simulation models. We create a model using a selection instantiated on a specific character, then we export it for simulation through an XML file. Based on this export, we can generate different simulation models. The first example shows the bones, ligaments, and muscles modeled using their 3D shapes and material properties. It can be used to illustrate the role of ligaments. In the second example, the muscles involved in the knee flexion are modeled using action lines and contracting according to a standard model to produce the movement. This can be used to study muscle activity. A geometric embedding is used to visualize 3D muscles. In the near future, we will work on an ontology representing mechanical simulation knowledge to propose a wider, customizable range of mechanical models. As a conclusion, MyCorporisFabrica is a new anatomy knowledge base useful for learning and simulating anatomy. We use anatomy transfer technology to warp available mechanical models to arbitrary humanoid characters. Combined with anatomy transfer, it is suitable to medical models as well as animation characters. MyCorporisFabrica, soon in your house!